Okay, picture this. You're at a carnival, right? The lights are flashing, you can hear the music, and you walk up to one of those games with a big, colorful spinner. The prize money looks really tempting, but should you actually play? Well, let's dive in and see how a little bit of math can actually give you a winning edge.
All right, so here's the deal. The guy running the game tells you it costs €5 for just one spin. You look at the spinner, you see the prizes. What's your gut telling you? Is it worth the risk? Let's take a closer look at what you could actually win.
Okay, so the spinner is split into 4 equal parts. If you land on 1, you win a single euro. Land on 2, you get €2. 3 gets you your money back, €5. And then there's sector 4. That's the big one, €8. I mean, an €8 payout for a €5 bet, that sounds pretty good, doesn't it? But how do we really know if it's a smart bet?
Well, to answer that, we need a special tool from the world of statistics. See, we can't predict a single spin. That's just impossible. But what we can do is figure out the average outcome if we played this game over and over and over again. And that is the key.
This amazing tool is called expected value. You'll often see it written as E of X. Now, I know what you're thinking. That definition sounds a little textbooky. The sum of all possible values, each multiplied by the probability of its occurrence. Yeah, okay. But don't worry, the core idea behind it is actually super intuitive.
The really important part of that definition is this phrase, repeated many times. Expected value isn't about trying to predict what will happen on your next spin. That's just luck. It's all about what happens when you play again and again and again. It's an incredibly powerful way to see into the future, but only for the long term.
So a good way to think about it is this. Expected value cuts right through the noise of short-term luck. It completely ignores what happens on one spin and instead reveals the cold, hard, mathematical truth of what happens over thousands of spins. It's the ultimate average, and it's exactly how we're going to find our answer.
All right, so how do we actually calculate this thing? You know, the best way to get a feel for it is to just walk through an example. We're going to step away from the carnival for just a second and head over to a magazine store. Okay, so imagine a store starts tracking how many magazines each customer buys. They find out that, say, 23% of people buy 1 magazine, 38% buy 2, and you can see the rest there. Our goal is to figure out the expected number of magazines a customer will buy. In other words, what's that long-term average we keep talking about?
And the process is actually way simpler than it sounds. It's basically 3 steps. Step 1, for each outcome, you just multiply its value, so like 1 magazine, by its probability. Step 2, you do that for all the possible outcomes. And step 3, you just add all those results together. That's it.
And here's what that looks like in action. We take 1 magazine times its probability, plus 2 magazines times its probability. And we just keep going, all the way down the line to 5 magazines.
Add all that up, and you get 2.39. Now, obviously, no single person can walk in and buy 2.39 magazines, right? That's the crucial thing to understand. But if you look at thousands and thousands of customers, the average number they buy is going to get incredibly close to 2.39. That is the expected value.
Okay, practice is over. We've got the tool. We know how to use it. Now, let's head back to that carnival. It's time to use expected value to figure out once and for all if that spinner game is a total ripoff or a real opportunity.
But first, we need to know what we're actually looking for. There's a term in probability called a fair game. And a game is only fair if, over the long run, you're expected to just break even. Your expected gain has to be exactly 0. You don't win money, but you don't lose money either.
So, to figure out if our carnival game is fair, our first job is to calculate the expected payout. Let's just totally forget about the €5 cost for a second. Let's just ask, on average, how much money is this spinner going to give us each time we play?
Well, since the spinner has 4 equal sectors, the probability part is super simple. The chance of landing on any one of them is just 1 out of 4, or 0.25. Every outcome is equally likely.
So now we do the exact same math we did for the magazines. We multiply each possible payout by its probability, which is always 1/4, and then we add them all up. So €1 times a quarter plus €2 times a quarter, you get the idea. And what does that give us? An expected payout of exactly €4. All right, let's put the two most important numbers side by side. On the one hand, we know that on average, over many spins, the game is going to pay you €4. But on the other hand, you have to remember, you're paying €5 for every single spin. Starting to see the problem here? To find our actual, true, expected gain, the formula couldn't be simpler.
It's just your expected payout minus what it cost you to play. So we take that €4 we just calculated, and we subtract the €5 cost.
And there it is. 4 minus 5 is -1. What this means is that for every single spin you take, on average, you are expected to lose €1. Yeah, some spins you'll win 8, and that feels great. Some spins you'll win 1, but over the long, long run, it will all average out to a €1 loss every time.
And that brings us to our final verdict. Because the expected gain is -1 and not 0, this game is, mathematically speaking, not fair. It's designed, like pretty much all carnival games, for the player to slowly but surely lose money over time.
So, there you have it. We've officially cracked the code on the carnival game. Now, let's just do a quick recap of the most important ideas you should take away from all this. Okay, so here's what to remember. First, expected value is really just a fancy term for the long-term average of something. Second, the way you calculate it is simple. Multiply each value by its probability and then add up all the results. And finally, remember that a game is only truly fair if the expected gain is exactly 0. If it's anything else, then someone, and it's probably not you, has the advantage. So, the next time you're faced with a bet, a game of chance, or even a big business decision, you now have the tool to look right past the short-term luck and see the long-term mathematical reality. And that leaves us with a final thought. Now that you know the secret to fair games, think about it. From insurance policies to picking stocks, where else in your life is expected value secretly at play?